and welcome to the stream where we present Moonstream, which is an open source blockchain analysis platform that we've been working on. I think I have no viewers right now. The meeting isn't set to start for another few minutes, so um, let's just hang out for a little while and eventually start the presentation. Instead of slides, I decided to use Excalidraw. Excalidraw is like an open source tool where you can draw images, and it really makes like nice hand drawn like images. So that's what I'm using here. Hi, hi viewers. Please send messages in chat. The way that we'll interact, because on Twitch you don't, it's only one broadcaster, and then so the way that we'll interact with is through chat. So you can just feel free to send messages in chat. If you have questions, ask them in chat. I want this to be quite interactive, so feel free to ask me any questions, and let me know if you cannot hear me or if you can hear me, but there's something wrong with the audio or anything like that, and I'll try to fix things as soon as possible. But I hope everyone's having a good evening or maybe morning, depending on where you are. And we're just waiting for a few more minutes. I think we'll get started in about 5 minutes. Let people sort of trickle in. Usually with these meetups, it's everybody working remotely. People in tech are still like mostly working remotely, I think, and it just takes time for people to trickle into these meetups. If you're viewing, please just say hi in chats and let me know if audio and video and everything are working fine. Do you see a cat over here? Hi Clarly, thanks for the follow. See Lorly. Let's just give it a few more minutes and then we'll get started. Everything that we're going to talk about on this Moonstream is fully open source. So all the technology that we're building here with Moonstream is fully open source. And it's available on GitHub. So the link on GitHub, if you would like to check out the code afterwards or figure out, if you want to get involved in any capacity, is here. So this is Moonstream GitHub. Okay. And then, and if you want to talk to us, um, you can also find us on Discord. So the Discord link is on GitHub, but here's a Discord link directly in chat. We do all of our work in the open, so frequently I think like we just do like pair programming, for example, on Discord as we fix bugs or build features in Moonstream. So we're usually hanging out in the Discord lounge, and anyone that wants to is welcome to join and to talk to us and to ask us questions and whatever. So um, yeah, please do join us on Discord as well. Yep, this is all right. Let's get started, and then if anybody joins, we can just ask them to post their questions in chat, or when we can circle back to any of the topics that we talk about after they join. So um, let me talk about what we think of when we talk about blockchain analysis, blockchain analytics, what that means to us, what we see as the future of blockchain analytics, and what kind of experiences we're trying to provide to developers and just in general users with Moonstream. So if you've been involved, I can tell you, I can start by telling you a little bit about myself. I'm a mathematician. I spent a large part of my life doing research in combinatorics and number theory, elliptic curves and things like that. And then I sort of got interested in technology because I didn't want to keep on working on stuff that basically a handful of people had any interest in, and didn't really have any bearing on anybody's life that I cared about. I sort of got interested in healthcare, and after I finished my PhD, I just moved to Japan and I started doing research on healthcare, on Parkinson's disease, and that got me into data science, and that's what brought me here. I live in Silicon Valley now, and sort of this transition through healthcare to data science is what brought me here. Um, I spend most of my time now programming and analyzing data and things like that. I've been involved in the blockchain since with like various blockchain communities since 2015, and I've been doing like a little bit of development. I wouldn't say a lot of development, a little bit of development on the blockchain, a lot of investing on the blockchain, and when I'm trying to figure out what kind of moves I should be making on the blockchain, or what kind of like technological or financial, um, I really want to know what other people are doing. And there are different ways of trying to figure out what other people are doing on the blockchain. There's sort of the social way of doing it by going to Twitter and going to Telegram channels and going to Discord channels and like talking to people. But the cool thing about the blockchain is that these what we're talking about are public ledgers, where basically when people do something, they're really doing it in the open. I mean, there may be some exceptions to this where it's a little bit harder to figure out what's happening in the open, with Monero, for example. But for the most part, when people do stuff on a blockchain, they do it in the open, right? Um, you can you can analyze all the transactions that take place on the Bitcoin blockchain or the Ethereum blockchain, or any one of these other ones, and it has to be open because the robustness of the distributed ledger depends on anyone being able to set up a node and participate in that ledger, right? That's the beauty of it, is that it has to be open. It's like public by nature. It's not public as like some sort of a coincidental choice that someone made, but it's public by nature. And so in principle, it should be easy for anyone to understand what's going on one of these blockchains because the data is public. But in practice, it's actually quite difficult, right? So it's like that joke about, in theory there's no difference between theory and practice, but in practice there is. And that's really true for blockchains as well. It's incredibly difficult to run a node. It's incredibly difficult to write the code that, pulls data from a blockchain node and analyzes it and so on. And that's why blockchain explorers exist, things like blockchain.com or Etherscan, or, all of these sites. They exist to make it easy for you to, without running a node, to at least, like, scan the transactions that are being mined onto a blockchain or something like that. But what we've been seeing since, I mean, we saw this in 2017, and then now we've been seeing a resurgence of it now, is that people want to bring more and more automation directly onto these public ledgers, right? So, for example, on the Ethereum blockchain, what started off as, like, ERC20 tokens and, like, that boom in 2016, 2017, has now sparked, like, another, sort of follow-on boom, where people are not just doing things with ERC20 tokens, but, the activities on the Ethereum blockchain are sort of being spurred on by not people sending money, like, to and from each other, or, like, making transactions on some of these ERC20 token contracts, but on people purchasing NFTs, like these collectibles, or on people, like, participating with decentralized exchanges or providing liquidity on decentralized exchanges like Uniswap, or, people borrowing and lending money using platforms like Compound. And in general, you can build pretty much any kind of automation you want onto the blockchain, as long as you have enough money to spend on it. People are creating these decentralized autonomous organizations. You can deploy arbitrary smart contracts to the Ethereum blockchain that sort of automate to whatever extent is, like, sort of mathematically or practically possible, pretty much anything you want. So we're seeing this, like, huge boom in people interacting with blockchains uh, through code, through smart contracts, and not just, like, directly sending money or tokens to each other. That's huge. Okay, um, because now, if you're, let's say that you're someone who's developing smart contracts, or you're someone who's investing, in tokens, or investing in NFTs, or, like, trying to provide liquidity on Uniswap or something like this, you have a lot of questions that sort of transcend just, like, that exist at a much higher level of abstraction than just, like, show me all of the transactions, like, in this window of time, or show me all the transactions, like, that this person initiated or this contract initiated on the blockchain. You really want, like, a higher level of interpretation on that information. Like, if you might want to know, like, okay, if you're a smart contract developer, is somebody trying to, like, find a vulnerability in my smart contracts that they're going to exploit, on a test net, so that they can actually, like, exploit it on the main net, or let's say that you're someone who's investing in NFTs. You might want to know, okay, what are the NFTs have that were minted in the last 24 hours that haven't yet been listed on OpenSea, or, like, or one of those, like, marketplaces for NFTs, because that way you can actually get in on the ground floor and purchase them, right? Um, because you can't keep track of, like, all of the Discord channels in which people are talking about all of this stuff. You really, like, need to somehow get this higher level of interpretation directly from the blockchain data, because it's impossible with, like, the number of people that are participating now. Where I think we're looking at something like tens of millions of people participating in the blockchain. When there were, like, a million people or a few 100,000 people who were participating, it was a smaller world. You could actually, like, feasibly say, okay, I know what's going on over here. I know what Vitalik is doing over there, and he represents, like, the majority of the movements on this blockchain, or something like that. You could sort of, like, keep tabs on things through gossip. But now, when there's, like, tens of millions of people who are participating in the blockchains, you really need, like, tools that help you make sense of big data in order to figure out what's going on the blockchain. And that's really what we mean when we talk about blockchain analytics, is tools that help you answer these higher level questions that require further analysis on top of the raw blockchain data. That's what we're talking about, and that's what we're building with Moonstream. Because the way that people interact with blockchains now, or that interact with blockchain data now, is and I do this all the time, right? You make a transaction. This is a classic thing. You make a transaction, immediately, like, go and look up the transaction hash on Etherscan or something, and to see when it got completed. Or if you're interested in some sort of an ERC20 token or some sort of an NFT, go and look up the address for that contract on Etherscan and see what kind of activity it's seen, right? And so you start off with like one page on Etherscan, and then you open a bunch of tabs to like sort of trace, traverse the entire graph of like blocks to transactions to addresses to other transactions, that entire chain of relationships through a bunch of tabs. And it's like pretty time consuming manual process, and it's quite difficult to sort of bring that higher like sort of semantic understanding of what's going on directly like this. And people who are more sophisticated will write scripts that like automate this crawling and stuff like that, but this is still not the way that it could be. It could be much nicer than this, because while Web3, while like the blockchain is new, in web development, we have tools that sort of make this easy, right? So if you're a web developer with your monocle and your top hat, and you put up like some sort of a web application or a website, all you have to do is like, throw like a little snippet of JavaScript in there that adds Google Analytics or Mixpanel, and you immediately start getting like these beautiful graphs that describe to you in like really great high detail at like a high level of abstraction what users are doing on your website. How are users interacting with your application? How are users interacting with your product? And it's really something that's very easy if you're in sort of the web development world. Um, with the blockchain, it should actually be that easy. In fact, it should be easier because all of the data is public, and you shouldn't even have to like go and put some code somewhere. You should literally be able to go to a website, and that website will be Moonstream, and say, hey, I want to know like how are people doing this? How long are people holding on to NFTs in like this new loot release or something, right? Like if you have those kinds of questions, you should just be able to go to Moonstream and get graphs that sort of answer those questions. Without even having to write any code. And that's the experience that we're trying to build with Moonstream. Right now, you can go on Moonstream. We have early access available. If you join our Discord, we'll show you how to set up your Moonstream account. You can view transactions that are taking place on the Ethereum blockchain and in the Ethereum transaction pool. We're also planning to add support for Polygon, as well as other blockchains like Solana in early next year. Right now, we're focused on Ethereum, and the experience that we're trying to build is, we're building much more than a blockchain explorer over here. We want to provide this kind of an analytical solution where, if you have like some set of smart contracts that you're interested in or addresses that you're interested in, you can set up a dashboard on Moonstream that says, on moonstream.to, where you say, okay, I want to know all of the time, like how long on average people are holding on to NFTs in this collection. Or I want to know every time somebody makes, let's say, a transfer of more than like 10% of these ERC20 tokens. I want to be like aware of that. I want to understand how frequently it's happening, and you will get presented with those things as graphs on the dashboard. And you can also get alerts for those events, over email or through a webhook to like some web service that you have running, so that you can then further take decisions based on those happenings, based on those events. So that's what we're building with Moonstream. I'll pause here. I should have asked at the beginning like how familiar people were with the blockchain or with sort of blockchain concepts in general, or how much this makes sense to people. If you have any questions, please feel free to ask in chat right now. I'll just wait for a few seconds while you process this, and then I plan from here to move on to describing how we've built Moonstream and how you can get involved in Moonstream if you're interested in doing so. So that's, and I'll share this stuff on the Discord after the talk. But there's more. There's 3 layers, 3 like columns of worth of these like images. So don't worry, I'll tell you right off the bat how many there are. And then the next phase, we're going to go into like describing how Moonstream is built. But before that, if you have any questions, I'll wait for a few more seconds. You can just post them in chat. Okay, Okay, it looks like there are no questions, but feel free like to interrupt me. Even when I'm talking, I'm keeping an eye on chat. That's the reason it looks like I'm not looking at the camera because I'm looking at chat on my second monitor. So if you have any questions, just feel free to ask me, and I'm happy to answer. Uh-huh. What kind of things have we found that developers want to keep track of? Well, the NFT market is booming right now. So a lot of developers that we talk to, they work at gaming companies or they're like, releasing NFT collectibles for games. And they want to keep track of when their users are selling those NFTs on secondary markets, right? So if you release an NFT as part of a game, you want to know what those users are doing with those NFTs outside of the game because those NFTs have like this completely separate existence from your game on the blockchain, and they want to be able to merge that information about what's going on the blockchain with the analytics that they're already collecting about their game. That's been a really big one for us right now, just because of how hot the NFT market is. And you can auction NFTs if you own one. You can auction one off on OpenSea or something like that. So the developers want to know what's going on over there. I hope that answered your question. Cool. All right, so let's talk about how Moonstream is built and some of the challenges that we've had building it and some of the technology that we're developing, like novel technology, in order to sort of solve those challenges, right? Um, so the way Moonstream works, this is how it works at a high level. There's like more detail, of course, as with any technology, any non-trivial technology. If you like dig deeper, there's a lot of stuff, a lot of like really low level details that you have to keep track of. But as a Moonstream user, you interact with the website at moonstream.to or with our API through our client libraries. So our earliest users are mostly like data scientists. They use Python in like notebook environments and Jupyter environments. And we released like the very, very, very first early version of our Python library last week, and we're working on an update to it, and we'll make an official release next week. But our users interact with Moonstream through the website at moonstream.to. You can go there in the browser right now, or through our client libraries or our REST API, so that they can get data directly through the Moonstream API. And both of these, the front end as well as the client libraries, they interact with our API, which is hosted at api.moonstream.to. And what the API does, and now this is where things get complicated, right? Because ultimately we're collecting data from nodes. So we run right now Ethereum nodes ourselves, and we have crawlers which take data from the Ethereum nodes and they put them into two types of databases. And this has been one of the complications with the blockchain, is that when you're working with blockchain data, there's two different classes of data. I would say really like three different classes of data. So there's data that there's like high volume data. So I would class, for example, Ethereum transactions as a high volume of data. You know, Even though Ethereum doesn't have a lot of throughput, it still like it's still pretty sizable because Ethereum is a blockchain that maintains state about every account that contained on the blockchain, and that state is pretty large. Like right now, if you're running an Ethereum node, uh, you should expect to use about 450 to 500 gigabytes of storage, and it has to be high quality storage like SSD in order to store like the Ethereum state and the Ethereum blockchain and its state and the associated state. And that's only increasing. Like the more stuff that people do on the blockchain, the more data that needs to be stored. And some people do like insane stuff, like store, I don't know, medical records on the blockchain, which is a terrible idea. But people think about those kinds of things and they try to do those kinds of things, and those things just sort of blow up the state that basically every node has to store. So there's like these things which involve processing a lot of data, but that data isn't very frequently accessed, or it doesn't. There's no sort of like very strong latency requirements in terms of access to that data, and it's expensive for us to store that data in like a high performance database which has like replication and like high quality storage and stuff like that. So we have a slow database into which we crawl like raw blockchain information. So this is where we put like Ethereum transactions, information about like Ethereum addresses and stuff like that. We have a slow database. It's a Postgres instance, with no replication. We back it up very frequently, but there's no replication on it. And it has like about 4 terabytes of magnetic hard drive that we use for storage there. And then we have a fast database. So again, everything that we do, by the way, is fully open source. So in theory, you could bring up the entire stack yourself. It's a little bit difficult right now, but we're trying to make it easier. Um, so for the fast database, we use a technology that we've built at bugout.dev in order to store very high volume volatile information like the information that we get from the Ethereum transaction pool goes into our fast database, but it expires, so we use it as a cache for that kind of data. And then also just like low volume data, like for example we run an Ethereum whale watch, which basically every 5 minutes we generate a report that says in the past hour these were the accounts that made the biggest movements on the Ethereum blockchain in terms of like the number of transactions they initiated, the number of transactions they received, the amount of ether they transferred out, the amount of ether they transferred in. So we just generate that report every 5 minutes, and we just store that as well in the fast database for quick access because that's something that people generally, it allows them to discover new stuff on the blockchain. So we have these two different types of databases. We have crawlers, which get data from the blockchain and write it to each of these databases. They might use side information from the databases themselves or from other websites. I should probably have an arrow sort of coming in from outside where we supplement our crawlers with labels that we find on coin market cap that helps us identify like which address belongs to which ERC20 token, or from we're going to add support for the Ethereum name service very soon, so that you can get the metadata about each Ethereum address that exists on ENS through our API. So we supplement all of the information over there. So really, the crawlers are the heart of these are the heart of Moonstream. The quality of the data, the availability of data, everything depends on how good these crawlers are. With the API right now, you can get direct access to blockchain information. You can get access to metadata that we've crawled about, like different addresses or different transactions or different transaction blocks through the API. But the important thing is, we're not trying to build a blockchain explorer here. The reason that we even have a slow database is because um, a slow database is really good for analytical work. It's perfectly fine for analytical workflows, and we don't have to directly serve data out of the slow database. What we do with the data in the slow database is we run machine learning models on it. We run like statistical aggregators on it, and those aggregates and the results of those machine learning models, they end up in the fast database, and this is really where we want to serve all of our live information to users from. So if you came in and you said this NFT just like this NFT collection like just released on OpenSea. If I get in now, am I getting in too early? Am I getting in too late? Like, is it still like the sharks who are buying these NFTs, or is it all fish now? And we're working on a model where we can classify NFT, owners, NFT purchasing addresses as fish or sharks or whales, right? And then based on those classifications, we can inform the developers of the NFTs, like what's going on over there, and then also the users who like just regular people who want to like participate in those markets. We can inform them like sort of what phase of dynamics that market is in, and that's the kind of information where we do analysis on the slow database, but then the results of that analysis go into the fast database so that we can serve them through the API. So we're moving towards that kind of an architecture where really like all the live service happens through the fast database. If you really want to crawl through transactions yourself or something, we don't want Moonstream is not for that, and we're sort of de-emphasizing that more and more as we move forward. Um, so the kind of data that goes into our slow database is raw data from the blockchain, right? So mined blocks, the transactions that were in those blocks, like a little bit of address metadata that we get from various places, smart contract call data, like what are the events that like these smart contract methods fired when somebody called them on the blockchain, that kind of stuff. But the data, this is stuff that you can very easily get from other places, and it's really not like our core strength. Our core strength is this stuff, right? So if you want like this volatile transaction pool information, you can get that through our API. If you want to have aggregations and summaries of activities that took place on the blockchain, in certain windows of time, you can get that through our API. Low volume data, this is like, if you want to know like what's going on with this NFT. You will have like every 5 minutes or every 20 minutes or every 30 minutes a summary of the activities with like particular NFTs that you might be interested in, and data whose value is short lived. So that's like the transaction pool data. For example, when transaction pool data goes into Moonstream, it it goes in with like a time to live of 60 minutes. So we delete transaction pool entries in Moonstream that are more than 60 minutes old, because otherwise we would just have too much data and we wouldn't know where to store it. It would become very expensive to store it. If you want to store any particular piece of transaction pool information, we are working on giving users the ability to do that in like separate storage for themselves. But right now it's just like 60 minutes and it's done. So that's the way that it looks. And for us, the important thing, as I said, is interpretation. And part of the interpretation is being able to understand automatically what's going on with smart contracts, right? So this is what we see as the future of blockchain analytics. This is what we see as the next step. It's not the far future. Literally, the next thing that we need to do as a community of people who are participating in blockchains is we need to build tools that can sort of automatically understand what's going on with smart contracts. It's not something, for example, right now, if you go to a blockchain explorer, or basically what they're doing is they manually add support for like uh, different contract standards. So for example, you know Etherscan has like manual support for the ERC 721 standard for NFTs or the ERC 20 standard for tokens, right? And so they only have those tabs for the smart contracts. If I made like a completely custom smart contract and deployed it to the Ethereum blockchain, some programmer would actually have to sit down, understand my contract standard, and then write the code that set it up so that Etherscan um, yeah, there will be a recording later, Laura. So yeah, welcome. There will be a recording later, and we'll put it up on our YouTube. It'll also be available on this Twitch channel. So for sure, there will be a recording. Um, yeah. So where was I? I was talking about understanding smart contracts. So a human being right now, a human being has to go and understand like what that smart contract does, and physically like write the code that integrates with that smart contract. But one of the things that we stand for at Bugout is static analysis and code generation, and we've been building tools for the last few years that just make static analysis easy and that make code generation easy. And we're working on a tool right now that does this for smart contracts. That tool is called Centipede. You can actually visit it. Let me put the GitHub link for Centipede up over here. I'll put it in chat. And what Centipede does is, you provide Centipede with a smart contract ABI, or you provide it with the smart contract source code. For example, on the Ethereum blockchain, you would give us Solidity source code. And what we do with that is we automatically generate a CLI that lets you interact with the smart contract, which is pretty simple. A REST API that allows you to interact with the smart contract. But more importantly, a crawler that can crawl all the information about that smart contract from the Ethereum blockchain, which has like the right crawling semantics, right? Like checkpointing, recovering from crawl failure, stuff like that. All of that code will be automatically generated once you give us the smart contract ABI or the source code. This means that if you wrote like some custom smart contract today, within a few minutes you could automatically have a crawler for that smart contract that would pull data from about that smart contract, put it in Moonstream, and then you could create a dashboard to understand how people were using that smart contract. All you have to do, you still have to understand the semantics of the smart contract to be able to analyze what's going on over there, but you don't have to do any of the other work that you would normally have to do of writing the code that got that information and made it available to you so that you could later on write a dashboard and do the analysis. All of that stuff we're automating away, and that's really sort of the cool part of what we're building with Moonstream. And that's what we see as sort of the really the very next step that we have to achieve as a community in order to go to the next level with understanding what's happening on these blockchains. So we're doing this with code generation. The way that we do this is we actually generate a concrete syntax tree. So given a smart contract, ABI or smart contract source code, if we get source code, we compile it to get the ABI. We generate a syntax tree for a program, a concrete syntax tree for a program that will do all of these things, and then we use that to generate the code. So right now we generate Python programs. We're planning to also add support for Go programs and JavaScript programs. But that's sort of where we are in terms of crawling. Um, and yeah, actually, that's I'm very excited about Centipede. I know I'm not very good at drawing centipedes. I need to get better, but this is like one of the most exciting things that we're working on. Some of the other things that we're working on that people might find interesting is running a cluster of nodes reliably is very difficult for crawling purposes. But when people are making financial decisions using the data, using your data, you do need reliability. So we're also working on clustering solutions for these nodes. So just this week, I think maybe tomorrow we're going to merge a pull request, which at least sets up like sort of clustering metadata on each individual blockchain node. And then we're slowly going to piece that together so that you can sort of build a cluster of nodes so that even if one node goes down, I mean, running nodes is not easy. This is the sad thing about running nodes. And with sort of modern blockchains, instead of making it easier to run nodes, like the creators of those blockchains have actually made it harder to run. Like it's freaking difficult to run a Solana node, for example, right? It was hard enough to run an Ethereum node. It's like difficult to almost the point of like impossibility for most people to run a Solana node. I don't know how it works on other blockchains. I think it's difficult to do it on Algorand. I think it's difficult to run a node on. I think Polygon is difficult for other reasons because they have like some limited capacity of nodes that can run on the Polygon network. There are just various things that make it difficult to run nodes. We're building tools that make it easy to run nodes in a cluster. Um, yeah, and then some other cool stuff that we're working on is with this transaction pool information, you really need to be geographically quite spread out to have like high fidelity view into sort of the global, let's say, Ethereum transaction pool. But you don't really need to run a full node. You don't need to be globally spread out with full nodes. So we're also working on sort of light clients, very, very light clients that can only participate in the transaction pool, but proxy like all the rest of the validation that takes place on a node to like the cluster of full nodes that we're developing. That's sort of the kind of technology that we think of. Most of our stack, like our API stack, is written in Python. We use Postgres for our databases. For the most, like actually all of our, we just love Postgres. And then our crawlers are written in a variety of different languages, using a variety of different frameworks, whatever gets the job done for the particular type of data that we want to crawl. So we have crawlers written in Go right now, and crawlers written in Python. But I think once we move to Solana, we'll have crawlers that are written in Rust. They're basically it's Wild West land when it comes to crawlers. But yeah, that's sort of an overview of technically how Moonstream is built. We It's a young project. We started working on Moonstream in July. It's already functional. It's live in production. But we're still in our very early stages. So the best way to get involved with Moonstream is just become a user. We would love your feedback. We're very active on Discord, and we're always listening on Discord. So if you have an issue or if you have a request or anything like that, just mention it to us. My name is Zonglings on Discord as well. Just add Zonglings and tell me like what you need, and I'm very happy to help you. If you're a developer, we would love to welcome you as a contributor on Moonstream. I'll spend a lot of time with you helping you get set up. I can help you set up a development environment and stuff like that. No problems. Just again message me on Discord. And if you're a content creator and anything about Moonstream is inspiring, like really this is a project that we're building in the open and that we're building as a community project. If you would like to get involved, we would really love your help to share sort of this common vision with the rest of the world. So we're looking to collaborate with people in all of those respects. Yeah, I think that's all I have to say. I'd love to just feel free to talk to me on the chat, and I'm happy to answer questions or just engage in a discussion with you guys. Yeah, so a smart contract, that's a good question. So a smart contract is a way of changing so it's a program that lives on the Ethereum on the distributed ledger, which runs on Ethereum. So it's not like some individual person is responsible for running that program. The program is run and validated by it can be validated by every Ethereum node. It's run by the nodes that mine it and a few other nodes as well. And what it does is it contains rules for given this input state or given these inputs and given the existing state on the Ethereum blockchain, within the scope that that smart contract has power, it might control some Ethereum resources, or it might control some parts of Ethereum state. Within that scope, what changes should it make? How should it change that state given like a certain bunch of inputs? So it's just a program that changes Ethereum state that lives on the Ethereum blockchain. That's what a smart contract is. So for example, ERC20, this was one of the first sort of uh, smart contract standards that took the world by storm. It's a smart contract that represents like some sort of a virtual currency, right? So let's say that I wanted to make I don't know, sparkling bucks, right? I like sparkling water, so sparkling bucks. I could release a token on the Ethereum blockchain that says, here's my initial supply of 1,000 sparkling bucks, and if and you can trade sparkling bucks with each other, and they might represent this utility. You can cash in sparkling bucks for like actual cans of sparkling water. Um, I could release that as a virtual currency on the Ethereum blockchain, and you could buy sparkling bucks because you would get a discount on like sparkling water that you like to drink. But later on, if you found that like sparkling water was bad for your health or something, you could trade those sparkling bucks to somebody else for ether, right? Um, all of that exists virtually, and it's a currency that's implemented on the Ethereum blockchain. It's not ether itself. It's just like sort of one level of abstraction higher than ether, and you can use it like in different ways. So you can plug it into, for example, a game, or you can plug it into like an authentication system on like some website or something like that. You can bring additional utility to sort of that particular abstraction without bringing that utility to all of Ethereum in the process. Um, Personally, I don't think ERC20. I don't think there's much value in ERC20 in the long term. I would rather do things directly with Ethereum or directly with custom smart contracts. But the craze right now is NFTs, non fungible tokens. So ERC20, that's a currency, right? Those tokens are fungible. One ERC20, if I have one sparkling buck, it's pretty much the same as another sparkling buck. It has the same value as another sparkling buck. If I have 5 sparkling bucks, it doesn't matter which particular 5 sparkling bucks I have. Okay, um, but with NFTs, they're non fungible tokens. Each token represents like an atomic distinct concept object, right? The first big NFT craze was CryptoKitties. Actually, it wasn't CryptoKitties. It was maybe CryptoPunks. I don't know if it was CryptoPunks or CryptoKitties, but I'll explain about CryptoKitties. Uh, this CryptoKitties were released, I think, in 2016, 2017. And the concept was like if you purchased a token, it represented a cat. And the cat looked a certain way. I can show you what CryptoKitties look like. Kitties. If I do an image search, this is what like the CryptoKitties look like, and you could breed CryptoKitties with each other. So two people that owned CryptoKitties could like breed their CryptoKitties to produce a third CryptoKitty, and it would actually generate an image that like looked like a mix of those two. Um, and each one of those was unique. And then what we saw happen was the early generation CryptoKitties ended up being worth a lot of money, and with each subsequent generation you saw like a decrease in value, except there were some CryptoKitties that I guess looked cool or something and they were worth a lot. Actually, we're going to be publishing an analysis of the NFT market soon where we talk about stuff like that, so stay tuned. We'll announce it in the Discord. But yeah, basically all of these things that I described are interpreted as computer programs that run on the blockchain, and they're represented by on the Ethereum blockchain by these things called smart contracts, where you actually put the logic on the blockchain, and that's as good a high level description as I can give. I hope that helped, Permafrosh. Asan Asansgiri, if you want API access to Moonstream, join us on Discord. We'll give you a registration link if you join us on Discord, and the documentation is a little bit lacking right now. We're improving that as we speak, but we have a REST API that you can use. And from the website, you can get an API token, and then you just pass it as a authorization header to the API, and you can start like you know reading data immediately off of the blockchain, the Ethereum blockchain, and from the Ethereum transaction pool. I hope that helps. Actually, I can give you the link. It's not, we aren't publicly broadcasting this, but if you just go to moonstream.to/register, you can create an account over there right now. Yeah, so I hope that helps. Maybe I can elaborate a little bit more on smart contracts if there are no more questions. The thing that gets people really excited about smart contracts is the fact that, these are contracts that dictate like what happens to your wealth, right? So the blockchain is like the Ethereum blockchain is the public ledger um, of wealth, and you can write a contract that says like, if these conditions are met, and only if these conditions are met, please automatically and immediately transfer this amount of my wealth to this person or to this program that performed a service for me, right? You can encode like your intention to pay someone, or to pay someone in exchange for value, as a computer program. And I think that's the thing that excites a lot of people about smart contracts. It still remains to be seen whether smart contracts are the way forward, or whether you need a model where like computation doesn't run on the blockchain but data lives on the blockchain, which you can do with Bitcoin. That still remains to be seen in the long term. But what's exciting about smart contracts is that you can encode, your logic about like, what you see as value and what sort of payment you will provide for value directly on the blockchain as public information, and anybody who provides that value, and it doesn't matter whether they're a person or a computer program or a cat or like a freaking centipede, it doesn't matter. As long as they provide you that value, they get paid. And so you can build like these, complex structures on top of the blockchain, where like you have entire organizations that run on the blockchain, where like, the legal functions are carried out by like this particular group of people or computer programs, and like the operational concerns are carried out by this other group, and the only interaction between them is, data and smart contract calls that live on the blockchain. I think that sort of vision is very exciting to people, and to be honest, it's exciting to me. I just don't see that it's economically feasible in the long term, but if it is, I could very easily be wrong about that. That's super exciting to me. All right. It looks like there are no more questions. If you do have questions, feel free to ask them now. But I think more importantly, do join our Discord. We're very active over there, and we're always looking to talk to people who are interested in the blockchain. Whether you're a beginner or an expert, doesn't matter. We're very welcoming of basically anyone. And if you want to learn more about the blockchain, or if you want to get involved with Moonstream or anything like that, just reach out. My name is Zomglings on Twitch. It's also Zomglings on Discord. So just like, at Zomglings, and I will respond to you. I spend most of my time there, and I'm just happy to help you with anything, talk about anything. And as I said at the beginning of the talk, we do a lot of pair programming, like mob programming on Discord. So we have like a Discord voice channel called Lounge, and usually once a day you'll find a bunch of us there, just like, writing code, trying to fix issues, or trying to implement new features. Right now, the project that we're working on immediately, like, for the next couple of weeks, is building a data set of the NFT markets from the Ethereum blockchain. We're using it as sort of like the very, very first test case of Centipede's crawler. So yeah, we're just like asking and asking interesting questions about NFTs, and then trying to write the code that helps us answer those questions. And actually, these days we're just every day we're discovering like some new interesting NFT that like we would otherwise never have heard about. So um, please do join us on Discord, and yeah, otherwise it's been a lot of fun. I really enjoyed this. Yeah, please join our community if you did as well, and I look forward to sort of engaging with you and collaborating with you in the future. Bye. I'll hang around for a little bit until feel free to leave, and then or feel free to ask me questions if you want. Just drinking my sparkling water. All right, my friends. Have a good evening or good morning, depending on where you are. Bye bye. Yeah, yeah. I think we'll keep the TTL the same for the Ethereum transaction pool. 60 minutes is a pretty good TTL for the Ethereum transaction pool, and if you need to store data long term, we're going to add the functionality where you can just make an API call, and for data that's interesting to you that does have a TTL on it, you can just copy it to like stable storage that's just private to your account. Yeah, so that's the way that it'll look. Basically, the kind of functionality that we want to build over here is like triggers, like webhook triggers. So basically, when something interesting happens, let me know. And let me know can mean like send me an email or send me a message on Discord or send me a message on Slack or post a request to like, my webhook endpoint over here. And then you can do whatever you want with the data that we post over there. So that's sort of the way that we want to build that functionality. And that way we avoid storing a lot of data. Like, for example, the Ethereum transaction pool generates a lot of high volume of data. We're talking something like 100,000 events, close to a million events per hour, depending on how large we set the transaction pool size on our nodes. Um, but even like we've been experimenting with crawling data from the Solana blockchain, and the Solana blockchain generates so much data that it's not really feasible for us to store Solana like mined block or mined transaction data directly on our slow database. It's just too large. Even the Solana team, like Solana is surprisingly centralized for a blockchain. I think like most of their nodes run on Google Cloud, and they store their historical transaction data on a cloud big table instance. So it's not uh, it's just not easy. So with Solana, we'll have a TTL as well for the blockchain data when we crawl it. But again, like if there's something that's interesting to you or important to you, that's usually like a pretty sparse subset of like all of the data that's taking place on the blockchain that we can store permanently, even in fast storage. That's not a problem. Yeah, my pleasure. I haven't done it recently because I've been doing less coding in the evenings. But I also try to stream on Twitch when we're developing something new or that kind of thing. So as long as it's not like directly related to um, a customer sort of bug or something that could violate someone's privacy, I also try to stream it on Twitch. It's been not so frequent recently, but I really enjoy it, so I'm gonna get back into it once time permits. I also have an 8-month old daughter, so that's also part of the reason why it's been hard to stream on Twitch. All right, my friends, it has really been fun. I really enjoyed speaking with you. Unfortunately, you could only chat back at me, but please do chat back at me on Discord and on subsequent Twitch streams. Have a good evening, everyone. Goodbye.